In this video, I show you how to use Claude Code to build an insurance claims AI agent team. To reflect real-world complexity, I use real car damage images, repair estimates, and policies. Then build 5 agents, intake, evidence, policy, risk, and payout. Also test the whole system with Evals and package everything inside a Gradio dashboard. Then I turn the whole build into a reusable Claude skill and Claude Code plugin with hooks. I'm Maryam, PhD with 20 plus years in AI, building and teaching production agents across 90 plus countries. Let's build together. Just before building, let me demo the final product to give you an impression. So let me show you the final product. It has a few tabs. The claim demo, it has this damage image. There is a customer statement, the vision damage observation, and then we have a repair state and a policy. So if we say we want to run the agent team, you can see that we have a final recommendation, pay, because the image and the claim matches, and the payout is this amount, and the coverage ratio is 80% as deductible. So it's just because it doesn't have any risk, it's approved. Agent timeline, the intake has been done, damage, policy, risk, and then payouts, which it says repair estimates, the coverage, 80%, the coverage cap, and the cross payout, net after deductible. The audit trail, we can see what has been done, exactly which steps and which decision has been made, and exactly which evidence. And then we have the confidence, that's really important. What kind of warning? If there is an image observation uncertainty, we will see that. And with the evals, 72 different evals, of 15 on routing, 10 policy, 18 risk, 14 payouts, and 15 on the image claim match. What did we catch by evals is that agent risk agent, it has a slicing silently disabled late reporting. So it's basically, it's just showing is this checklist. And you can imagine you can always come here and read it. Really quick, if you want a deep dive for real-world AI agents, completely for free, 30 minutes plus AI agents best practices and also production AI agent. The first link is in the description. 46,000 already joined. Hope to see you there. Okay, let's build what I have just shown you. This is our build route. We go from rules, specs, data packs, state agents, graph, evals, dashboard, and finally to our skill plugins. We use actually Claude Code to just kind of build the layers, but then we have a full process in a reusable builder. So Claude Code builds actually the code. Well, what kind of code do you want? We want always a Python code in a specific framework. So as I have it in my agents mastery, we have LangGraph, Pydantic AI, Crew AI, OpenAI, Google ADK. And LangGraph is the first framework in the course as well, because it's a graph, it's a state machine. It's so suitable for so many applications, especially here in our claim. So Claude Code built for us the plan, the scaffold, the code, the test, the refactor. But LangGraph is the one that orchestrates the agents, and we execute and track state or add some human in the loop. So Claude Code is the builder. LangGraph plus some Pydantic AI is the runtime workflow. What do we want to build? We need to give some rules. We want a hands-off with the structured data. We want some evidence, so claims must be grounded. And we want also our audit trail to do every decision logged. It's important to route anything risky cases to human experts. I'm inside Cursor and I open Claude Code. As I said in my previous videos, create a CLAUDE.md, then give all of the rules, the agents you want, the system, the output, and run it. Because we are going to use BMAD later on, we are not going to use plan mode. In the directory, we are just putting our data. He's building the CLAUDE.md. CLAUDE.md is ready. Project purpose environment, the stack. We already told LangGraph and Pydantic AI, the UI Gradio, our agents, our tools, data, UI, and all of the evals that we need. The architecture rule, no unstructured text between agents, really important. Audit log, human approval routing, no invented policy rules, test coverage required, all of the 5 agents, claim state, system input and output. config key conventions, LLM.md, and also audit log. So for vision model, I prefer GPT image. So I'm going to tell that. They change it to 4.0. I can just change it to 5.6. So with Claude Code, you need to think like an architect because we used to write every line of the code ourselves, but now we kind of help Claude Code to write what we want. And the goal of your product is very important. What kind of roles do you want to give? Then we have the routing rules, failure modes, what kind of evals we want. And we put everything as a plan in a build spec because we want actually our specs. In my video about specs, I have tried 5 different plugins and BMAD was actually the winner overall. So I'm going to use BMAD for that. Let me show you. So this is BMAD method and the GitHub install BMAD. I use BMAD help -- use the BMAD planning and give me this production style insurance. Ask him to interview me and give me a planning output. I make sure that BMAD is in the skills directory. You can use the fast path or coaching path. I chose the fast path. It asks me 5 things. I just answer everything. So he's now writing all the 3 planning. So the brief MD, the PRD.md, and the synthetic claims MD. And here you can see it has looked at our images and built actually these CM garage door side, drive-through, real end, and these are some of our images. I just ask him convert all these 3 markdown into one clean implementation ready build spec empty. So we've got our build spec, layers, image story mismatch, scenarios in the high risk, high payout, agent roles and responsibilities, intake agent, LangGraph workflow, routing condition, human approval, evaluation cases, acceptance criteria, and out of scope. Anywhere you go, the first question that you have to ask is what kind of data you have, what can I work with? So we have to ground actually our agent team before coding. We want to ask what kind of images do you have, because we need to do some vision observation, the claim stories, where are they, repair estimates, policies of the company, claim history, and anything will give us actually an expected output. As the data of insurance companies is privacy sensitive, we're going to build that synthetically. I'm going to use real image data from Kaggle and then also build a bunch of synthetic data around it so we have this grounding. Let's now build the data package. First, create image observation. I tell him where are the car damage images. The image observation is ready. Then run the create image observation. It creates the severities and the confidence. Low, medium, all done with the 20 images and written to image observation JSON. Lookup 1 is a scrape, paint transfer, image clear but does not provide information. The rear bumper shows visible scrapes and paint transfer, and that for all of the images. The next prompt is read that JSON generates synthetic insurance claim stories based on the visual observation. It's now creating claims JSON, 12 matching claims, 4 slight mismatch, 2 strong mismatch, and here is the customer statement. It also created some dates, also if the type is matching. Next, we ask to generate for us repair estimates and give actually the structure. So repair estimates is actually added, the realistic cost, total estimate of cost, and then estimated plausibility, reasonable, this one is high. Now we are asking to create insurance policies and what should be inside those policies. So now we have 3 policies, or the basic, premium, and exclusion. And they are all in the policies, showing what is covered and not covered, and deductible payouts, manual approval, and then we've got it also for exclusions, for example, intentional damage, and the premium policy. The next data that we have to create is claim histories and the customer data. So as you can see, a huge part of our time is spending on data. And if you are already tired and you want actually to go and code, it means that you're not built for being a data science or AI engineer, because to do that, you have to care about what kind of data, what kind of input it is, and the garbage in, garbage out. The fact that now the code is written for you basically reduce just a small fraction of your work your main work has been always to understand business and data and analyze it and get the output that business wants from you. We get also to the fun part and the agents, but most of the time is less than 20 or 30% of your work. So it reads the claim JSON and both files has been written. The claim history and the customer just generates some names. And also what kind of risk do we have with them. I'm checking how is the context window doing. 83%. So it definitely has this context rot. So I'm going to start a new session asking for the next data, which is like the expected outcome. And that context rot is basically what ChromoDB has shown in their technical report that shows that your context window, it doesn't matter how big it is. When it's bloated, it just everything you have becomes noise after a while, and then performance drops significantly. The trick is always to have your data as JSONs and markdowns. So it doesn't matter how often you restart the whole session, just clean your context. It has all of the context to read from those JSONs and markdowns. If you have a lot of parallel work, you can start new sessions. For example, the Git work tree to just create feature branches and then run them at the same time. Or you can use sub-agents because it's also use fresh tokens. Remember, you can't use it when things are kind of independent on each other. Like the data that we made now, all of the steps were kind of dependent on the previous steps. So it's now writing for us expected outcome, 12 auto approve, 8 human review cases, and then just shows actually our triggers and put them in a JSON. So now we've got everything, but normally you get those data and then data engineers will audit everything, will check if everything is okay. So let's help them with audit. So the last prompt for data is audit the full package. Do we have all of these information, the claims and the reports? Is the data realistic? And I run it. It's starting to say where it's passing. For this one, F12, a specific data point, just fix it, removed from image observation, updated to 90, claim summary, and 12 auto approve. So we audited our work. Just really quick about MIA Agent Mastery 71. You build real world AI agents in 15 different industries as an accelerator using Claude Code, an advanced module for enterprise-ready projects. You get lifetime updates completely for free, 60% off. The link is in the description. Hope to see you there. So what's actually important is that the state is the real backbone. So we have to put everything into that claim state. So claim input, image observation, policy, that give us our risk assessment, payout recommendation, and audit evals. For an insurance case, we want a payout recommendation, also with all of the confidence that we have. And also we want to evaluate what we are doing. Are we good? So now we're building actually our agents. Like each agent has one job. Like you can have the intake one, who just validate the claim. The evidence one compares images, story, and estimates. Then we got the policy checker, coverage, exclusions. They've got a kind of score, like what is inconsistencies. And finally, we've got that payout that needs to go to the next department for payments. Let's build like a project skeleton. We ask read Claude.md and build a spec, the agent's core data, evals, UI, scripts, also requirement txt, and readme.md. As you can see, I don't immediately jump to building it, because if you build, then you get this code that's just kind of very long, very difficult to debug. But when you build it like layer for layer, you can see that. In my first project of Agents Mastery, my course, I also tell that build agent by agent. So what you do is just create this empty skeleton. Then you fill in the agents, then fill in all of the core tasks. And then after that, we do some evaluations. For the core, auditing, ClaimState, data loader. So agent needs tools. And these are our core. Also writing evals. The skeleton is complete and gives me a summary of everything that he has done. It says he needs some format as structure that should be machine readable. It's important to take the time and just go for the quality, because later on in production, you just have less headaches. All of these instructions are inside my course. I start to build all of the agents. First, the intake agent would load and normalize data, update claim state, and add an audit event. All 4 scenarios pass. Now we are asking him to make the damage evidence agent. Looking at the first agent, we can see that it has normalize, confidence, and reasoning. For the damage evidence agent, it's looking at everything which is like related to the images, observation, risk thresholds, and repair estimates. This agent is just kind of cross-using a lot of those data. When building it, so everything's working correctly, we now have the damage evidence. As you can see, expected damages, it just gives us 3 categories: collision, glass, and vandalism. Damage evidence, score the damage, alignment, reasoning, no image results. The reason that this is so extended is that we are writing production agents. So in real world, you have to cover all of those edge cases and problems. That's why every agent kind of have 10 different tools to cover the risks and the problems, the categories, and those kind of things. Let's build the next agent, which is policy agent. I'm going to go ahead and build also risk agent in a parallel window. It's all about risk score and risk level. Also in a new session, the payout agent, which is our last agent. This is about a policy decision, human review. And we see if some of the agents are not quite aligned, we can just solve that afterwards. Otherwise, you're doing these too linearly. Let's take a look at the policy agent. It's loading the policy, parsing date, exclusion clause, confidence reasoning, and policy unavailable. It's racing with the tokens, so see if we can do it. This is for me as a coder, like I have coded for about 30 years, is that it's just really strange to let the code be done, especially because I know that bad code exists. I can do some kind of how to simplify these codes, because overcomplication is what these AI agent codings actually kind of default mode. We want actually the code to be separated and to be debugged easily. We have also skills to check for that. I'll just make some videos about that one as well. But for now, we've got also the risk agent ready. So all of them are ready, but still we have to see if all of that in one system will work. So we've got this routing logic, because the agent team doesn't just run itself, but it routes. Like we have a claim state, we have routing rules. If we have missing evidence, we have human review. If we have image mismatch, again, human review. If it's not covered, no payout. High risk, human review. Low risk, payout recommendation. That's how our routing works. Let's now bring all of the agents together with graph.py and routing.py. Does all of the checks, 10 check functions and router nodes. Think of missing fields, intake complete is false, human review. Check excluded coverage, coverage decision excluded, then you have to reject it. So it is done and it's in the core, and you can see all of the nodes actually here. And a graph builder is the state graph of LangChain. So we have a number of nodes, edges, and conditional edges. So if we want to have it in a graph, we will go to start, intake, damage evidence, policy, risk, payouts, router, which will say rejected, human review, or auto approve. And we go to the end. So that's actually what's inside this graph. The routing is obvious, it is this part. Checking the context. So I'm going to ask for a JSON log, for audit log, with everything. So remember I said we need to audit everything. We see everything is working. So it's going through our intake agent, our evidence agent, one by one look at things that may or may not work and just adjust everything. Come up with a confidence, key fields captured. So we build Evals. We do not want to ask that question, does it work? Just randomly answer it, but we want to actually see if the routes that we have determined works. We've got this expected outcome versus agent decision, so about image claim match, policy decision, risk levels, payouts, human reviews, Does it match or does it mismatch? Because if it mismatch, we need to fix it. Now we're done with routing. So we can now go ahead, build our evals. We want it actually to be as good as possible now that we have everything. And we want to use at least 10 claimed cases. So let's run it. Okay, now all of the tests has been built and fixed all of the problems. 72 changes. It's about 9 escalation, 15 tests, 10 tests. So this context is quite full. So let me just open a new one. So the whole system is, we've got our claim inputs like claim damage, prepare estimates, policy, claim history. It goes through our 5-agent team. And then finally we get these outputs: coverage, decision, risk score, payout recommendation, human review route, and then also an audit trail. I'm going to build a complete Gradio dashboard from everything that we have built. I give also some colors. I'm going to give it the tabs. Each tab should contain, first one, claim demo, second one, agent timelines, third one, audit trail, evals, and ask it to build. The Gradio app, you already have seen it. And the code is basically this app.py, which is a Gradio app. I will get the information, build an UI with a Gradio, and create all of those tabs. Of course, what's the most important part is this intake, damage, policy, risk, and payout is the audit trail and everything that happens, because then the expert can check and changes things. And the eval, we of course have also what's happening every time. You can just run the evals for like every 3 months and get some results if anything actually is changing. There you have it, a complete product. And most importantly, it is production, and it just gives you the final decisions and the trails. In my video about Claude Skill plugin and hooks, about the features, I told how important these features are for building reusability, basically. We basically turn this full workflow into a reusable engineering package. Let me show you. As promised, let's build a reusable skill from this whole build. So the skill should teach Claude Code how to build this kind of production style insurance. It should have purpose, when to use, build stage, non-negotiable rules, output format, and then keep the skill practical, structured, and reusable. And let's run it. So the skill is live. It's in the available skill list. And if I check, that's correct. Let me open it. And now you can see all of the steps that we have done is now like a skill. If I'm in Claude Code and I say insurance, so /insurance claim, you can see it is a skill that will give me an insurance claims AI agent builder. And if I activate it, it will just say, oh, I will build all of the 12 stages. So basically, by just invoking this /, I will go through the process of the 12 stages that I show you. It's a lot of work, it says, and let me go and audit everything. I will start to ask all of these questions. So basically, we have now packaged everything in just one command. So you saw how valuable BMAD was in this whole project. So I have BMAD plus another 4 plugins for creating specs, plan, and implementation. It's really life-saving in complex projects. It's quite valuable for you. So I see you in that video.